Hey, it's Molly. Before this episode starts, I want to let you in on a little secret, which is that Radiolab is doing an Ask Me Anything about our recent episode, Snail Sex Tape. So the AMA is going to be with myself and our producer, Mona Medgaoker, who is like a snail expert, a snexpert. And you can ask us anything, how the episode got made, how we came up with the idea, do snugs really exist? So come to the AMA on April 16th. Now, the catch is, in order to come, you need to be a member of the lab. So if you're not a member of the lab, go sign up now, fools, so you can come see us. Go to radiolab.org/join, radiolab.org/join. Use code SNAIL so you get a discount on your first year of membership. And as a thank you for signing up right now, we will send you an enamel snail pin that we are about to drop. It's very cool. We all want it on our jean jackets. So I can't wait to see you April 16th. And until then, we have a really great episode for you today. It is a story Lulu and Latif reported back in 2022 all about the chaos and messiness of life. And I'm talking life with a capital L, like the kind that evolution gets involved in. So let's go listen.
Yeah, wait, you're listening?
Okay.
All right.
Okay.
All right.
You're listening to Radiolab.
Radio
From
WNYC.
See?
Yeah.
Rewind.
Okay, so let me just, because I also don't entirely know what's going on.
I'm Lulu Miller.
I'm Latif Nasser.
And we also have with us producer Matt Kielty.
We have 3 different pitches.
Yeah, we're going to, you guys are
we're doing 3 different things?
Yeah, but mine's very little. But you got to leave me 15 minutes at
15 minutes, okay, and then, a little context. A while back, the 3 of us found ourselves in a studio together because our editor, Soren, he knew that we were independently working on these 3 different stories. So you don't know that, Lulu, you do know the stories or you don't know the stories?
I don't know. And unbeknownst to us at the time, he decided that each of our stories pitted chaos versus order in a way that could upend some of our deepest beliefs about how life works.
Yeah.
And so he wanted to just get us in the ring together.
It's a cage match. It's a story cage match.
Yeah. And we'll get to all that. But
should I start?
Yeah.
Latif has got story number 1.
All right. Okay. So we're starting at the University of Rostock in Germany.
Yeah, the story started here in Rostock
with this ecology professor named Hendrik Schubert. Did I pronounce that right?
Absolutely great. You got it.
So back in the early 80s, Hendrik finishes his undergrad degree in ecology at Rostock, studies in a couple different departments there, goes on to teach for a while at a different university.
And when by chance I got the professorship here in Rostock in my former department,
he came back home.
It was really by chance. I never dreamed of.
But the job was department chair. So basically now he was going to be the boss of his former teachers.
Yes.
Awkward.
Yeah. It's kind of a funny dynamic, right?
Mm-hmm.
Anyway, one day he walks into this temperature-controlled lab that they have there, and he sees one of his old professors.
Mentor of mine, Reinhard
Heerkloss.
Yeah, my name is Reinhard Heerkloss.
And right next to Reinhard, he also sees, much to his surprise,
I saw this barrel.
A bright blue 100-liter barrel.
Yeah, my barrel for my experiments.
And Hendrik knew this barrel.
When I was still a student and we had a practical course where
Because as an undergrad, he had done this experiment with Reinhard where they had filled these barrels full of seawater.
Brackish water from a lagoon of the Baltic Sea called...
And they were tweaking the nutrient levels just to watch how it would affect the, tiny microorganisms living in the water.
Like copepods, zooplankton.
But it was a simple little experiment that had only lasted for 2 weeks. And now... more, a decade later, Reinhard still had that barrel, just sitting there.
So I asked Reinhard, hey, what are you doing with this? And he told me.
So Reinhard then tells him the story.
So I can go back to the late 80s.
So a few months after the initial experiment in 1989, something unthinkable happened.
The big jump in history.
The Berlin Wall fell.
The Berlin Wall fell.
Rostock was in East Germany, and all of a sudden, just felt like overnight, everything changed. The currency changed, the head of state changed, the university changed its name, its curriculum. Like all these very specific things about Reinhardt's day-to-day life all of a sudden just changed.
Yeah, it's the cultural shock.
Cut to 6 months later, June 1990. In all the chaos, Reinhardt had totally forgotten about the barrels until one day, a colleague of his in his department wanted to do a different experiment, and so came to him and was like, hey, could you, it was just bugging him, like, could you just get those barrels out of there?
I was asked to remove these barrels for their own experiment.
So he does it one by one. So he like takes the one, he like shimmies it over, he dumps it out.
Empty the water and wash out the sediment.
Takes the other one. So he started doing that. And then he gets to the control barrel, which is the one in the experiment that they had done nothing to. It was just sitting there under a light source, right? It was, as a comparison for the other barrels where they were tweaking things.
Okay.
And like for some reason, he's about to tip it over and then he stops himself. And he's like, you know what? Let me just like take a little sample of this and look under a microscope and see what's actually like in this barrel.
Is there still life in it or is it not in it?
And so he looks at it and he's totally dumbstruck by what he sees.
Sample filled with many, many organisms with zooplankton and algae and so on.
I mean, he hadn't even touched this thing in months. Nobody had.
I thought that there will be nothing, just more or less dead.
But when he looks, he sees that it's not just alive, it's thriving. There's like tons of different species. So there are phytoplankton. These are like little plants, and a lot of them are green. Zooplankton, which are basically like the animal-y type of plankton, some of which eat the phytoplankton, some of which eat the other zooplankton. And then there are bacteria, which are basically like the equivalent of the mushrooms or the whatever that are recycling the whole system. Unwittingly, he had created a little natural world.
Quick question, clarification.
Yeah,
did he create it or did he just preserve it?
Yeah.
I think it's like a semantic thing.
That's what I love.
Like sure. So maybe he didn't create it, but he
sustained it.
He didn't sustain it because he didn't touch it. It just happened. It's like a thimble of ocean that he got, and somehow this thimble of ocean is continuing to live.
Okay. Cool.
Okay, so also when he sees that it's alive, part of the other reason that it excites him is that at that time in the 80s and 90s, there was this kind of open question in the field of ecology about the natural course of an ecosystem. And I'm kind of like bastardizing the question in a way that I understand it. So like, but this is basically, I think, what it is. If you could just give an ecosystem the basic things it needs, right? Like sunlight and space and whatever, but there were no humans around to mess with it. No comets, no earthquakes, no outside confounding factors. What would happen? What would that ecosystem do?
Huh.
Cool.
Okay.
And there's sort of two options here. Like it might be that all the creatures get, to some certain population level and with a bit of eating one another and more being born over here. And then it basically stabilizes, beyond the day-to-day up and downs. It basically is like a line in the end.
Like a never-ending line of harmony.
Yeah.
Okay.
Or maybe would you see like more like a cycle? Like there would be more of one thing for a while and it would dominate for a while, but then it sort of crashes, and because there's not enough of another thing for it to eat, and then another thing takes over, and then instead of so in this case, instead of like a line, what you have is a circle.
A circle of life.
That's right. It's what Mufasa says in The Lion King, the circle of life. That's the song, right?
Yeah.
So two options, line or circle, which are kind of just two flavors of balance.
The prevailing view was when they are left alone, the nature tend to get balance.
But here, in this barrel, Reinhardt thought, I have the perfect opportunity to answer this question. I've got an ecosystem that's totally untouched by humans. And the species in that ecosystem are born, reproduce, and die at a super quick clip. So in just a few months' time, I'll be able to see like hundreds of generations worth of transformation. And so he starts tracking how the various species are doing. Week after week, He's like interrupting Christmas with his family because he's like, I gotta go, sorry. Looking at and scrutinizing like a glass of water over and over and over again. And everyone's like, this is the most boring thing. Like even his colleagues who are like scientists who do boring
Gotta go check
other
in
stuff.
on my stale water.
Exactly. They are all like, this is like, they're like, what even is this experiment? But from another way, it's like, he is a god overseeing a tiny universe where he is watching it, and it's like generations are passing in effectively the blink of an eye for him. And he's watching this like very dramatic story unfolding, but he's trying to figure out like what exactly is the shape of it? Like what is the plot?
He's like, am I in a suspense movie? Am I in an apocalypse?
That's exactly what's happening. And he can't figure it out because what he is seeing, it's like a microbial Game of Thrones or something that he's like watching. Like the species that are there, they're booming, they're crashing. One type of creature could be the dominant species in the barrel for hundreds of generations, and then just, it's a blip from then on. Like it just crashes and then it never comes back.
It's like Rome rises, thinks they're going to be on top of the world forever, and then the barbarians come and they're like, oh, hell no, it's Germany now.
Right, okay. Right. And he watches this play out in this barrel for over 6 years, waiting for the harmony.
Oh.
And he just never...
It never came?
It never came. No line, no circle.
In this nutshell of a small ecosystem, nature is chaos, chaos, chaos.
What Reinhardt had discovered in this barrel was that this tiny ecosystem, when left to its own devices, was completely chaotic.
So what does that mean? Like, is that saying it's just booming and busting at random, or does that mean...
Well, so...
First of all, maybe I should tell a little bit what chaos is.
Please.
Because for most of the people, chaos is just total random, but it's not.
This is Elisa Beninka.
I'm Elisa Beninka, and I'm a theoretical ecologist.
Reinhardt brought her in to analyze his data, and she says the way to think about chaos is not whether it's random or not, but to what extent we can predict what's going to happen.
So actually, a chaos is a system which is high predictability on the short run, but cannot be predicted in the long term. And the weather is actually the best example for that. Meteorologists can do forecasts up to 2 weeks.
After that, they're no better than you or I trying to predict the weather. And in the case of this barrel...
Species could be predictable for around 15, 30 days. After that, you couldn't know who is going to be in advantage.
Huh. So it's not like, things are just happening completely randomly for no reason whatsoever. It's just that we, like it's beyond us to see why things are happening or what's going to happen, which to Reinhardt, suggested there's no line. There's no circle. Like harmonious natural balance, that's all BS. Like at any moment, the natural equivalent of the Berlin Wall could fall and just upend the whole system.
He told me, I never have seen a stable state.
So when Hendrik, the student turned department chair, ran into Reinhardt and his barrel, Reinhardt told him about all of this data he collected.
Sometimes I had a stable state for some weeks or even months, but then suddenly the system shifted again and I decided to follow up.
And then with, the help of Elisa and others, Reinhardt gets his work published in Nature. And according to Hendrik, there was this immediate blowback from some other ecologists.
Yes.
Because it sort of thumbed its nose at this whole field of study. Like,
if this is true, why should we do any research anymore?
If we're trying to bring a system back to order and you're saying there's no such order to begin with, what the hell are we even doing?
Well, if there is chaos in nature, why do we do restoration or whatever?
But, Hendrik, he was also skeptical of the result for scientific reason. Because, even if Reinhardt found chaos inside this one barrel...
It doesn't mean that chaos is something mandatory. He showed that there might be chaos.
Hendrik is like, I'm redoing this whole thing.
Really?
Let's see what happens. So this time he repeats the experiment.
similar setup and improved setup.
Try to control for all possible variability.
To get our best, let's say.
And
for a year, twice.
With 8 barrels this time, they scoop and measure, scoop and measure, scoop and measure,
etc.
What did you and your colleagues find?
We had signs of chaos in some of the vessels and in some of the compartments tested.
So not all 8.
Not all, and not always the same.
Like when there was chaos, it was playing out in different ways in the different barrels, which provides me at least with a little sigh of relief, because in some ways it's saying like we still don't know.
Or is it just now like a multiverse of chaos where we can't even tell if it's going to be chaotic or when it's going to be chaotic? Like I just see deeper chaos, which fine, I'm okay with.
Really?
Yeah.
For me, reading about this study, I found it quite jarring. I think I really wanted there to be like a hidden order to everything that is not about us, that has nothing to do with us, where things make sense. And for that not to be there, I think is very unsettling. Like when we do conservation or restoration or whatever, it just feels like you'd be throwing your hands up.
My thought was like, if the order is gone, if there is no guaranteed harmony, that actually makes conservation work even more important. It's like if we don't intervene and protect the order, it's not guaranteed.
Who cares about your choices if it's chaos anyway? If there are things that are beyond your control that are gonna
happen,
screw it all anyway.
It's like the idea of the moral arc of the universe bends towards justice. I don't think it does, which is terrifying. So what you have to fabricate a form of justice. And yeah, there's a pandemic.
Wait, can I interrupt you?
Yeah.
Okay, write that version of The Lion King. See how many kids go to see that.
Okay. Ready?
Yeah, do it. Go, make the song. Elton John, go for it.
Okay. Numanaya singing Numanaya.
I'm very excited to hear what's coming next year.
Simba, based on the work as confirmed by Reinhardt, there is no delicate harmony awaiting you. And if you don't choose wisely and show respect to your fellow creatures and plants and bacteria and fungi, everything will die. The balance is not delicate. The balance is not there at all. And the song is not the circle of life. It's the giant abyss of no promises vortex of life.
But then why are we going to watch any of the rest of the movie? Like, even if you're a Lion King, your Lion Kingdom is going to, like the Roman Empire, it's going to crumble and fall. Right. And like, who cares?
Oh, I for sure think that's coming. I think we're probably out of here pretty soon, but let's make it decent for the other humans and creatures that will get to live in this short future. Sure. Yes.
Okay, so that was round 1 of our chaos off.
Yeah, so we're going to take a quick break, and you can use that time to really ruminate on whether you believe chaos is totally empowering and great,
or has let all the air out of your spiritual balloon.
And then when we come back, round 2, we've got another Smackdown Order vs. Chaos coming up from producer Matt Kielty. Lulu.
Latif, Radiolab.
And we're back.
With Matt.
Okay, so my turn?
Yeah.
I think I see how these things go together, because Latif has this little barrel ecosystem that was in chaos, which is not totally random, but is like a weird, wildly fluctuating thing.
Right.
But I have a story that kind of like steps that up, because we found a part of life, you could argue the most important part, where it looks like things are actually completely random. And I say we because...
Hello.
Hi. Can you hear me?
Heather. We can hear and see you.
I reported this story out with our contributing editor, Heather Radke.
Yes, yes, yes.
And Heather actually first heard this story from this guy, Chris Hoff.
Thank you, Heather.
Who's a philosopher of science
A lot of times
at Case Western Reserve University.
Yeah.
Chris, how did we come to the story? You wrote me an email and said,
I have a great story for you.
Yeah. You're like, I got a hell of a tale.
Exactly. Strap in your seatbelts.
Okay, so we're going back in time
to some big collars, cool music.
Back to late 60s, early 70s, and to this guy,
Professor Gould, the floor is yours.
Stephen J Gould.
I want to start by presenting the basic argument in a somewhat abstract form.
Maybe you've heard of him.
Darwin, in fact, never said that.
Oh, yeah. Oh, he's the greatest. He's one of the best science writers of all time.
In his new book, Full House.
Yeah, he wrote some big deal books. Mismeasure of Man is one.
Right.
Wrote a lot about evolution.
The fundamental principles of Darwinian theory.
A lot about the history of science.
But before Gould was a public thinker, he was just a young man who really loved fossils.
He had like the kind of classic moment
where his dad took him to the American Museum of Natural History.
I was 4 or 5.
To the Hall of Dinosaurs.
He sees the T-Rex.
I remember standing under the Tyrannosaurus and a man sneezed. I thought the Tyrannosaurus had come to life and was about to devour me, but after that moment of fear, I just let fascination creep in.
He was like absolutely hooked.
Oh, I didn't know that. That's cute. That's his
And Gould says after that moment, this fascination with fossils just started to unlock all these questions.
Questions like, why are we here on this earth? What are we related to? How is the earth built? What has its history been through time? What's been the pageant of change over this immense span of years?
So Gould felt himself drawn to the field of paleontology,
the study of fossils.
But that actually became kind of a problem for him.
Because paleontology was not really seen as like a real science.
You don't really get to answer big fun questions in paleontology.
You kind of look at a lot of fossils.
Yeah, Heather, you described it as stamp collecting. That one. Yeah, I mean, this is the problem that Gould was attempting to confront. You know, if we're going to survive as a science, we need to find a way of contributing answers to important questions.
So in 1967, Gould gets his PhD.
And he's immediately hired at Harvard.
And then one day,
this guy, Tom Schopf, he's a paleontologist at the University of Chicago,
called up Gould, said he'd read some of his research and he'd been wondering
if they could do anything really cool, basically, with computers and the fossil record.
And Gould's like, oh, that could be something.
So the fossil record is like everything we humans know about what existed before us.
It's what allowed us to start thinking about evolution. It kind of became the foundation for Darwin.
And for this guy, Schopf, he thought, well, maybe there's actually still something in there. And we could use these new powerful machines to pull it out and start answering some big important questions.
Why are we here on this earth?
And so Gould
what are we related to?
Was just like, yes.
Yeah, exactly.
Okay, so let's set the scene. It's like
1972.
Schopf,
Gould.
Right. And they invite this guy, Dave Raup,
another paleontologist,
who had done these really cool studies
looking at seashells and geometry.
And then there's this fourth guy, Dan Zimberloff,
an ecologist who was really into, mathematical modeling.
So we got 3 paleontologists and an ecologist.
This, by the way, sounds like a beautiful beginning to a joke. 3 paleontologists, an ecologist, and a computer walk into a bar.
Yeah.
Okay. It's the winter of 1972.
These 4 guys go up to Woods Hole, Massachusetts,
where there's this sort of holy grail of fossil records.
This fossil record of marine life.
Marine invertebrates.
What are we even talking about? Like shellfish or what?
Yeah.
Mollusks?
Yeah, mollusks, ammonites.
Oh, sure.
Trilobites.
Yeah,
I mean...
your various bites.
Yeah, stuff on the seafloor.
And in this book, for each species, it basically has
where this first appears in the fossil record, where it disappears in the fossil record.
So they grab this book, they go to a house somebody had.
And then they go to the computer.
Take their big book out, they start entering all the data. And then they're like, okay, what next?
I mean, the problem, a computer you can't just say, computer, make a cool thing. You have to ask a computer a question.
And you get the sense that they just did not know what question to ask the computer. They didn't have a good question to answer that evolutionary theorists would care about.
So, for 5 days, they don't know what to do.
And then right before, it's like the last day, Raup is like, what if we have the computer simulate evolution at random?
And why would they do that?
Well, because evolution,
is not a random process.
Right. Darwin established it's small incremental change over long periods of time.
But it's not just that, right?
Oh.
It favors certain things.
Right. Yeah.
And it favors adaptive traits.
Right. The fittest survive.
Yes.
And if you're not fit,
you just die.
You get wiped off the face of the earth because the strongest push you off.
Because they're better suited for the
Right.
niche.
They're better than you.
Yeah, right.
What a bunch of jerks.
Way of the world. But so all they had was this really simple question.
Right. If things were just happening by chance, what would we see?
So what they do is they make a computer program and let's say they start with a species in this program. They don't give that species any definable characteristics, anything like that. It's just this nondescript species.
Can you just name the species just because?
Yeah,
helps
let's
me?
call it Bloop.
Okay, Bloop.
It's just this bloop, blah, bloop.
Mm-hmm.
And then they program the computer so that it's an arbitrary number. It's let's say 100 years. 100 years of Bloop living. The computer's okay, I now assign all of you Bloops one of three things at random. So thing number one could be nothing happens to the Bloops. The Bloops just get to keep on living, go through to the next round.
Mm-hmm.
So that's one option. Or the computer could pick number two, which is a little tweak to Bloop. And from Bloop, you get bleep, 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 bleep.
bleep.
Bleep. Bleep, bleep. Whole new species.
So it's just bloops?
Bleep, bleep, bleep.
Then it's bloops and bleeps.
Yeah.
Bleep, bleep.
And they could go forward and they can go to the next stage.
So number one is nothing happens. You move on. Number two, you can change, evolve, speciate. Or the third thing that can happen is
Bloop, 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 bloop.
bye-bye bloop.
Dead.
Extinct. Dead. Forever.
Bye-bye bloop.
R.I.P.
So that's it. 1, 2, 3.
Live,
Live,
die, or
die.
speciate.
Rock, paper, scissors, shoot.
Yeah, exactly. And the computer's picking them at random.
Okay. So they produce these simulations
Running bloop after bloop through this program.
over millions of years.
And then they go to the computer, they print it out, and all of a sudden they see something pretty bananas.
Which is the simulations that they produced looked remarkably like the actual fossil record.
Wait, what is that?
I can share a screen.
Chris showed us these graphs.
Okay. So this is a graph of the actual fossil record.
For the sake of this, just imagine tree of life sort of evolution, image. And you can see, okay, mollusks, they start here, they die here, and trilobites, they start here, die there.
And then Chris showed us the graphs of these simulations.
You see this one over here?
Oh.
Whoa.
Basically, if you were to zoom in on these branches, you'd see at the end of each of the branches the extinction points of the species. And the ones from the computer are the exact same as the ones from the fossil record. So bloops and bleeps are going extinct just like trilobites went extinct, just like ammonites went extinct.
So for me, it's I'm wow, yeah, these do look similar, but I'm so what?
Yeah.
So
Okay.
what? So what?
So I think the key here is kind of seeing the resemblance that these randomly simulated groups bear to real groups. And then remembering that these are just going extinct randomly, whereas we thought these were going extinct through natural selection.
That is wild. So it's just computer programming equals life itself.
Computer programming of nothing but chance and randomness, which is totally counter to the sort of order of natural selection.
So natural selection would be you've got a bird with a awesome beak and cool eyes, and it's can fly like a baller. And then there's a lesser bird that's kind of a weenie bird, and it's got me, it can't see in 3 dimensions, and it's not good at sports. It's basically this is Heather Bird.
Weenie
Heather
bird.
Bird.
You're
Heather
really
Bird.
projecting
Heather
yourself
Bird.
onto Weenie Bird.
But in this kind of scenario, in the Darwinian idea, it's athlete bird with its great eyes, its great wings, wins the evolutionary battle. Heather bird goes extinct. Weenie birds as a kind of bird, as a species, cease to exist. But what these computer simulations were showing is that extinction doesn't work that way. And that actually Heather weenie bird and super athlete bird have equal chance of not necessarily thriving, but like existing.
So it's like if those two species were born at the same time, weenie bird and athlete bird, it's up to chance which one would survive longer than the other one.
Right. So fitness might explain why one species does better than another. But what they saw suggests that when it comes to extinction, it's not fitness or outcompeting one another. It's just random.
But
it's a little hard to get your mind around.
But wait, but I have a question. Going back to that marine, there in Woods Hole, what did they all, do we know what they thought at that moment?
Yeah, we do.
Well, they were all totally shocked.
Like the way
Crystal, just the way he heard it is basically
when, the printouts come out, they're like, oh my God.
Also, we should say it's at this point that we got Chris a better microphone.
This is a mic gain of 8.
Yay, Chris, you sound great.
Anyways, but basically, they were kind of freaked out because the idea is, if Darwin can't explain why things go extinct, then the question is, why do things go extinct? Is it just chance and randomness?
And that question would send the three of them off in very different directions.
So Gould, he actually, this was mostly just a big huzzah moment.
Because paleontology had sort of knocked down a piece of Darwin and put forward this new question.
Yeah, exactly.
And as Chris put it,
they put paleontology at the high table.
But Gould kind of leaves extinction behind.
It goes back to what I said at the very beginning, that we want to know why we're here.
And he starts using randomness and chance to look at things like diversity and adaptation.
And to a large extent, it is a grand-scale accident that we're here. Evolution has oddly contingent pathways. It would never run the same way twice.
And he starts writing all sorts of books. He becomes kind of famous Stephen J Gould. But then Raup, the guy who came up with the question to ask the computer, he becomes obsessed with extinction.
And stays on that track for the rest of his professional career.
He ends up writing this book, which I have right here. Extinction, bad genes or bad luck?
Oh, question mark.
And to Raup, the answer was it's both. You can't discount fitness. But when it comes to extinction, there's so much other stuff happening. The climate is changing, or an asteroid hits Earth, sea levels can rise and fall drastically. All of that stuff is outside of your control. You could sort of die at any moment. So he sort of charts this middle ground view, which is probably how Gould saw it too.
But then you have Tom Schopf, the guy who started the whole project, and he just goes full randomness.
The impression that I get was pretty much from the word go, he was randomness is the order.
Schopf developed this idea called species as particles.
Species as particles in space and time.
He believed that if extinction is truly random, then as a whole, species are sort of indistinct. They have no real differences between one another.
That there are no better or worse. The way he puts it, there's no inferior or superior beings. There's just ones that survive and ones that don't.
Schopf began writing a book trying to flesh out this theory. But in 1984, at the age of 44, he was in Texas doing field work with students, and he died suddenly of a heart attack.
While reporting this story, we talked to some paleontologists, and we're who, do we know? Is it sort of the Raup, bad genes, bad luck? Is it the Schopf, total randomness? What drives extinction? And the answer we got is that we still don't know. We still haven't answered the question they sort of uncovered with this computer in Woods Hole.
Well, I gotta say, I'm rooting for Schopf. If it doesn't matter how quote unquote fit or muscly or well honed or sleek our model is, if that doesn't relate to how long we're gonna hang around on Earth, it means in a very real way, we're all equally good. And for me, it creaks open all this possibility that might be waiting behind things that we look at and deem unfit or deformed or weenie bird-esque. It gives all this, it returns all this possibility that gives me a sense of thrill. Like it makes me want to look at the things I'm discounting, you know?
Totally.
I don't know.
I'm not sure. Because, okay, so to me, it's this, right? Like, let's say we used to have this idea of fitness where it's like, okay, there are the cool kids who are fit and they, in the old mentality to be like, yeah, like this is like, we're Team Human. There's some people that get picked first for Team Human who are the ones who are helping us survive. And some people who get picked last for Team Human who are like us. But then it seems like this, if it's like, oh, okay, your survival actually, even the fittest people, like they're not necessarily helping you survive. Those super fit characteristics, like you could still get hit by a bus and like that's the way they go. So it's not like, oh, now all the people who are picked last on the team, like they have the same chances of survival. But it's not like the people who are picked last, they aren't now brought up to the team of the people who are picked first. It's like the people who are picked first are now brought down to the level of the rest of us, where any of us.
But that's the same thing.
No. This is what when Lulu was talking, I'm like, no, it's just a matter of perspective, and it's like everything has the same value, which means it's like wonderful and beautiful, or everything has the same value, which is it has no value.
It's pointless and defeated. Yeah,
right.
But that's kind of awesome. That's great.
And it's great, yeah. And you can sit in either reality and bask in that. It's just up to you which one you want to bask in.
Yeah.
Did you want to reflect, Matt, about how it had changed you?
No.
Yeah, do it. Do it.
I want that.
Well, I mean, the only thing I would say is that, like, one of the things we learned when reporting the story is that 99.9% of all things that have ever existed on Earth have gone extinct. Basically, everything that's ever lived has eventually died. Whether or not, like, and it seems like chance is a big part of that, but we don't fully know, but whatever, everything dies. And I've sort of maybe naively always existed with this thought that, like, we as a species are progressing towards something, like some sort of better world eventually for us and, I don't know, other species. And kind of really believed in the idea that, like, in some way, your actions, the actions that you take, the things that you do are rewarded in some way to continue to strive towards something better. And instead, in doing this reporting, it's like, oh, no. You, your kind, and every other kind eventually just gets wiped off the face of the earth. You have no foresight. You don't know it's coming. It just happens. And not only does it just happen, but like in the long run, it happens to almost everything. And I guess in some way I'm like, it just feels deeply nihilistic. And I'm kind of like, well, what are we doing here?
This is making me think of a song for The Shape.
A song with a shape?
I was like, okay, if it's a circle, yours is telling us it's like, it's the cliff of life, and we're all gonna die.
Who knows where and when?
So why even try? Just eat some French fry.
When we come back, we're going to take the chaos question all the way back to the beginning.
For our final round of this order versus chaos throwdown, just to stir the pot or the barrel a little bit, I have with me a special guest who is going to...
In person, you have a special guest?
Yep, they're going to beam in now.
They're beaming in?
They're beaming in, so just wait. They're coming.
Oh my gosh.
They're coming.
Oh, it's
Candice!
Hi, everyone. I'm back.
And all is right in the world now.
So Candice Wang is our former intern, and she is the one who got us into this final mess when she told me that we should take a closer look at how it all began.
Do you guys have a sort of thing you think about when you think of the origin of life?
Sure.
In the ocean?
Primordial ooze?
It's like cauldrons of heat.
Heather, did you just say primordial ooze?
Yeah, primordial ooze.
Oh, isn't it soup? Is that? I don't know, that's how I remember it.
The primordial soup.
Maybe that's right.
So it's this idea that life somehow emerged out of this crazy, chaotic soup of chemicals, which I remembered learning about in the 9th grade.
Yeah.
Yeah, me too. I even learned about it on this very show a few times.
Yeah, I remember that.
But apparently the reason that the primordial soup theory is so widespread all goes back to one singular experiment done in 1952 that involves a
bowl of soup, can of soup. Please tell me.
Barrel of water?
A cauldron. It involves a cauldron, but it's kind of barrel-esque.
Or like a glass flask or something.
Yeah. So Candice, okay, tell us about the experiment and who our guy was.
Okay, so our guy is Stanley Miller, this grad student in 1952 in Chicago. And
I'm looking at Stanley Miller.
Oh, there's a picture. Should we look at it?
Like what you see?
Somebody took a sexy pic of him. They did. It's like
I see Bill Nye, the science guy with no hair, fondling a globe full of lightning.
This is the sexy photo you're talking about?
Yeah, it's kind of. I kind of feel like, come on. I mean, I think sexy's too much. It's too much. But look at
he's got swagger. He's got science swag. Anyway, Candice, sorry, please go on.
yeah, so he's looking for an experiment to do and thought of this old theory from 1920s, basically that primordial soup theory that we just talked about.
The theory had been floating around, but it had never been tested.
Yeah, and so Stanley was like, okay, I'm going to test this out.
He took his little cauldron, filled it with all these gases.
There's like ammonia, hydrogen, methane, all those things that people thought were in the early atmosphere. And then he was like, okay, I'm going to create a little storm. And he zapped it.
Like a bolt of the early Earth's lightning.
Yeah, lightning, basically. And he's watching the cauldron for only a day. And then he finds that it starts turning a little pinkish. And he's like, oh my goodness, like, is there something going on here? And then a week later, it turns deep red, turbid red.
Like smoky red?
Yeah, it's like rusty blood red water that's collecting at the bottom.
Oh, the water's becoming red. I see.
Yeah. So it is kind of like a little like red soup at the bottom.
So he pulls this red borscht out of the cauldron and he looks to see what's in there. And he finds
amino acids.
Amino freaking acids.
Wow.
The stuff of life.
So, like, does anyone know what an amino acid is?
The ingredients of DNA, right? Like,
well,
it's like that's
but it is the ingredients of pretty much everything else in the cell. So the little motors and enzymes and all the stuff that actually makes a cell work.
Yes, amino acids, the building blocks of life. So it was a kind of almost a meme as an experiment. It's a beautiful experiment.
So this is Nick Lane,
Professor of Evolutionary Biochemistry at University College London.
And he says that as beautiful and scientifically fantastic as Miller's experiment was, the idea that it explains the origin of life is a bit of a leap.
You know, going back to Frankenstein, the idea that you have electricity and lightning and you zap things and they come to life, they spring to life, and all you need is another lightning strike and lo and behold, you know, fast forward 4 billion years and we've got humans. You know, if that doesn't persuade a 13-year-old, well, good, because it doesn't persuade me either.
Huh. Why not? Like, what's wrong with that?
Well, Nick says, you know, amino acids are great and all, but
it's another 10 or 12 steps to make something living.
To make an actual living thing that can make copies of itself, you need RNA and DNA and a cell membrane and all the intricate goodies inside.
This is asking a lot of spontaneous chemistry, that all of these steps should just happen without anything to direct it.
How do you get from just a bunch of ingredients in a soup to like very structured, complicated life? That's a very, very far gap to jump.
I mean, Miller himself worried about this during his lifetime.
Yeah, but the most famous critic of this whole primordial soup idea was actually Francis Crick.
As in the guy who helped discover a little thing called DNA.
Nobel Prize winner Francis Crick published an extraordinary book called Life Itself, in which he argues from a scientific point of view that life could not have got started on this planet.
So this is a snippet from a call-in radio show where they are discussing what Francis Crick saw as a far more logical explanation of how life began.
So to cut a long story short, he suggested it was sent here by an alien civilization from the other side of the universe.
Yes, Francis Crick proposes what he called directed panspermia, which is to say some alien civilization put some bacterial cells on a rocket and crashed it on the Earth.
One of those spaceships crashed into the early Earth. Its cargo of bacteria spilled out and eventually became us. And that's honestly how Francis Crick, the Nobel Prize winner, saw the beginning of life on this planet.
Yeah, seems more feasible than a glass cauldron.
Than a lightning bolt.
Than a lightning bolt.
I mean, my immediate reaction is that it's bonkers, but there's a kind of less extreme but more real version of that, which is that organic molecules can form in space and will be delivered to Earth on meteorites. And that's definitely true. That does happen. There's no question about that.
What?
But if you
Okay,
meteorite...
wait. We got to... Okay, the
Yes?
resident person who knows less here. I mean, what?
Well, plenty of amino acids, the same amino acids that Stanley Miller had produced, that all of those have been found and more.
From space?
In space, yes.
How are they found?
Because they arrive on meteorites, or people have occasionally taken samples of things, but mostly from meteorites.
And Nick says it's not just amino acids.
Bits and pieces of the building blocks of DNA have been found there as well.
That's wild.
Yes. It's amazing that this cosmic chemistry happens and is delivered to the Earth. And so maybe they had something to do with the origin of life. Yes, maybe, but...
For Nick, as a full way to explain the origin of life, that's still...
that's 2 steps too far.
Even if amino acids or DNA apparently are always raining down from the sky, you still have those 12 other steps he mentioned.
How do you get it to do the things that cells do, which is to say grow, divide, and copy itself?
And so his best guess for how, or rather where life began, and he's scientific, he's like, this is just my guess, I'm not saying it is a particularly hellish spot that looks very not conducive to life.
I personally think life started in deep-sea hydrothermal vents. You can get these vents anywhere. Some of them can be very deep, 5 or 6 kilometers down.
Way beneath the surface of the water, far from any sunlight, where the heat from inside the earth is churning up and creating these craggy rock structures.
They can be beautiful spires, pinnacles of rock, 60 meters tall. I mean, I like to think of them as Gothic cathedrals or something. They're full of little details, little doodles of rock. They're beautiful things to look at.
And according to Nick, they've got the goods. They've got the materials, the right chemicals, methane and carbon and hydrogen are swirling around in the water. They've got the energy source, not lightning, but this constant churn of the Earth's heat. But finally, what he thinks make them really special is their structure.
The amazing thing about these vents is they mimic the structure of cells, in that it's kind of a round space with a wall around it. And you can think of a cell as a kind of a bag of solution with a membrane around it.
And because you've got the materials, the constant churning energy, and these rock walls that kind of force everything together.
That's making these gases react together to form organic molecules, which are forming inside the pores themselves. They will form spontaneously in this kind of environment into what we call protocells, a little bit optimistically maybe, but effectively a membrane around a bag of water with some stuff inside.
It's like the matter and magic you need to make life is lush there. It's like you got it all.
Yes. It's got the right materials and it's got the structure. And I think that's what's been missing from the chemistry, and it's what's missing from the soup, and it's what's missing from, delivery of organic molecules from space by panspermia. It ends up in a soup. How does that soup form structure? Well, the Earth itself forms the structure for you in the first place in these hydrothermal vents. There is a beautiful link between the geology of the planet with active volcanic systems and active turnover of the surface of the planet and the bottom of the oceans, and the way that living cells work. It's as if a living planet gives rise to living cells, which have the same structure. They're both the planet and the cell is a little bit like a battery. It's got a positive charge outside, a negative charge inside, a membrane surrounding it, and they're both like that. And there's a lovely sense of continuity that a planet gives rise to living cells.
Wow, that is very cool. But Lulu, like you've been championing chaos this whole time, and now you're serving up a story that's like this to me, this is order. Like you're putting order right back at the beginning of it all.
Well, that's interesting. I mean,
Like the soup or the panspermia are both like very chaotic. Like some random thing just fell to earth, or a random lightning bolt hit a random, piece of gas at the right time. Like those are pretty chaotic. But if it's like, oh, look, there's this chimney that was being built, and there are a whole bunch of them, and they have the exactly right gradient and the right this and the right that. Like then it's a very orderly
the cell
thing.
is a tiny planet. I guess. I mean, I was seeing Nick's explanation as yet another loss.
Yeah.
He's pointing out that our beginning, even our scientific beginning, isn't as clean of a story as we thought. There was no lightning strike, no clear moment where it all began. Just this slow and like bad breath out of a vent, churning, clumsy mix of chemicals in a dark, dank pit. To me, that rips away the last shred of order that I thought the old soup version had,
Huh. Yeah. I don't know, because it's like, to me, it sounds like maybe at the very beginning of life, there was an orderliness built right on top of the orderliness of the planet itself.
You are making me think, if I focus on the structure of the vent and the cell, there is a sense of belonging in that. Like every cell in our body looks a little like this planet. Maybe we don't matter, and the fact that we're here is random, but we do belong.
It's okay, I said everything is chaos. It's okay, I said everything is chaos. It's okay, I said everything is chaos. From the day we arrived on this planet, in darkness and far from the sun, there is more that we need than just lightning can seed. More chance that it would never be done. And as we fight for our place here, competing through struggle and strife, you can't anticipate who gets to dominate in the contest for the greatest in life. It's the chaos of life that confounds us all. Choose despair or hope. It matters not till we lose our place on this path that's grinding. It's just
Guess that's it. This episode was reported by Latif, Nasser, Matt Kielty, Heather Radke, Candice Wang, and me, Lulu Miller.
It was produced by Matt Kielty and Simon Adler, with sound and music from Matt Kielty, Simon Adler,
And Jeremy
Bloom.
Big thanks to Alan Gafinsky for creating that song, and Alita Gafinsky for belting the heck out of it. Thanks also to Chuck Cheeseman, Sarah Luderman, Doug Irwin, Candice Wang.
Thanks to David Sepkoski, whose book Rereading the Fossil we drew on for the story about Stephen J Gould and extinction. Thank you to Nick Haddad, Ayana Johnson, Chris Klausmeyer, Laura Verhaeg, and Noel Bowen.
That'll do it. Thanks for listening. Goodbye.
Hi, I'm Gabby. I'm from the Bay Area, California, and here are the staff credits. Radiolab is hosted by Lulu Miller and Latif Nasser. Soren Wheeler is our executive editor. Sarah Sandbach is our executive director. Our managing editor is Pat Walters. Dylan Keefe is our director of sound design. Our staff includes Jeremy Bloom, W. Harry Fortuna, David Gable, Maria Paz Gutierrez, Sindhu Naina Sambandan, Matt Kielty, Mona Mudgaukar, Annie McEwen, Alex Neeson, Sarah Kari, Natalia Ramirez, Rebecca Rand, Anissa Vitze, Arian Wack, Molly Webster, and Jessica Young. with help from Gabby Santis. Our fact-checkers are Diane Kelly, Emily Krieger, Natalie Middleton, Anjali Mercado, and Sophie Samai.
Hi, I'm Maddie, and I'm from Frederick, Maryland. Leadership support for Radiolab's science programming is provided by the Simons Foundation and the John Templeton Foundation. Foundational support for Radiolab was provided by the Alfred P. Sloan Foundation.